Hello friends, in our previous lecture we have completed exercise 1.1 and we have also taken the introduction about exercise 1.2. In that we will have now to find the probability using the formula of mathematical definition, that is P of A, or probability of any event is favorable outcomes m divided by total number of outcomes n, and we have seen that all the elements are equiprobable. Due to that, now we are starting exercise 1.2, page number 25, sum number 1. A balanced coin is tossed 3 times. Page number 25, exercise 1.2, first sum I am reading. Read, please be careful. A balanced coin is tossed 3 times. Find the probability of the following events: getting all the heads, not getting a single head, getting at least one head, getting more than one head, getting at most one head, getting less than 2 heads, getting head and tail alternatively, getting more number of heads than tails. So friends, what is the change between exercise 1.1 and exercise 1.2? In exercise 1.1, we were asked the sample space for first 5 sums. For the other sums, we were asked to write the elements of the events. Now what will come in 1.2? In 1.2 we have to write the sample space, we have to write the elements for different events, and also we have to find the probability for it. Only that is the change. So let's see the sum, how to do that. Now first thing, to write the sample space for a balanced coin tossed 3 times. How to write it? Let us see it. Okay. So exercise 1.2. First sum. Sample space for a balanced coin tossed 3 times is. Now friends, if you don't know to write the sample space, I will guide you how to write. See, when there is only one coin, then head and tail. Then where are 3 coins, or a coin is tossed 3 times. See, there are 2 possibilities. One coin 3 times or 3 coins 1 times is the same. Now how to write first? Write only first this much part. H means HH, then H and T, then T and H, then T and T. How to do? As we are doing cross multiplication, H into H, HH, H into T, HT, T into H, TH, T into D, DT, into H and T. So now what will be done? H with H, HT with H, TH with H, TT with H. So what we have done? We have written HH with, we have written all the 4 elements with H. Now all the again 4 elements with T. So change the line. H then T, H T then T, T H then T, and T T T. So our n will be 8. Why 8? Because there are 1, 2, 3, 4, 5, 6 and 7 and 8 elements are there. Okay? So our n is 8. Or you can say that 2 cube 8, because 2 into 2 into 2 is also 8. But when you don't know how to write the sample space for 3 coins, you can do HT, HT, HT. Now first you should do for only 2. H into H, HH, H into T, HT, T into H, TH, T into D, DT. Still one H and T is there. So for all the elements write SC, HH, HT, TH and TT. With all the elements I am writing H, H, H. Now with all the elements I am writing T, 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 T. Elements are same. Okay, so this is our sample space. Now in that, see, this one number is the question number 1. Now again number 1 is their event. Event A is equals to getting all 3 heads. Getting all 3 heads. So elements of set A will be only single element. There is only one element with all the heads. Now favorable outcomes are 1. See, in 1.1 you only to write the sample space and a set. Now in 1.2 for you need to find a probability. So for that, see, we have counted the elements. There are here we have counted the not 3, only one element, because one element is only having this triple H. So m is 1. So probability of event A as per mathematical definition, m by n, 1 by 8. In this way you have to find the probability. Only one change is there. In sample space you count the elements, that is our n. In favorable outcomes also, in set A also you count the elements, that will be our favorable outcomes m. So probability will be m by n, 1 by 8. Okay. In the same way, now second one, event B. Now what is written second question? Not getting a single head. Not getting a single head. Now favorable elements will be only one, because in all the elements there is one time H. Only in the last element there is no head. So it is again T. So m is again 1. Again probability of event B, m by n. Again the answer is 1 by 8. In this way only you have to do. Very easy. Okay. Now, third point under that, event C. Getting at least one head. Getting at least one head. Now, at least one means one or more. What do you mean by at least one? One head is also okay, one or more is also okay. So the elements of event C will be one or more. See, here it is 3, it is also done. 2, 2, 1, 2, 1, 1. So in short, we need head one time. 0 is not acceptable. We need minimum head one time. So all the elements will come except this, because here head is not one time. Here H is not there. Okay. So all the elements, right? Triple H, HTH, THH, TTH, HHT, HTT, THT, and that's much. Okay. So our M will be 7. Why 7? Because there are 7 elements which are having at least one, means they are having one or more than one head. Now probability of event C, m by n, so 7 by 8. Very simple. Number 4, event D. Now what is event for D? Fourth one, getting more than one head. Getting more than one head. What do you mean by more than one? 2, 3 heads. Because maximum there are only 3 heads. We need more than one. So 1 is not acceptable, more than 1. Now which are the elements? This is okay, this is also okay, this is okay, this is not okay, because we need more than 1. So these 3 elements will come, again this also will come, and no other elements. So 4 elements are there. HHH, HTH, THH, and HHT. So m is equals to 4. Probability of event D, m by n, 4 by 8, we can cut it as 1 by 2. Number 5, event E. Now what is given in event E means the 5th question, getting at most one head. Getting at most one head. Now at most one and at least one are to be understood carefully. At least one means one is acceptable, more than one is acceptable. At most one means 0 is acceptable and 1 is acceptable, not more than 2. Okay, not more than 1 is accepted. So in short, 0 and 1 head. 0 is also acceptable, 1 is also acceptable, but not more than 1. So elements of set E, 0 head and 1 head. This element, this element, this element, and this element. Okay. So TTH, HTT, THT, and triple T. So 0 head and 1 head. So elements of E are 4. So P of E, M by N, again 4 by 8, again 1 by 2 is the answer. Next, number 6, event F. Getting less than 2 heads. Getting less than 2 heads. Less than 2 means 2 is not okay. So 0 and 1 heads. Now it is the same thing. 0 and 1 head. At most 2 means 0 and 1, maximum 1. Getting less than 2 means 0 and 1 head. The same elements will be same, okay? So same elements we will write TTH, HTT, THT and triple T. Again the elements will be 4, P of F, M by N, 4 by 8, 1 by 2. Now 7th question. Getting head and tail alternatively. Event G. Getting head and tail alternatively. Alternatively means one after other. Okay. All are heads, not alternate. Head, tail, head. This is acceptable. Head, then tail, then head. This is not acceptable. This is not acceptable. This is not acceptable. This is also not. Again, this tail, head, tail. So there are only 2 elements. So G is equals to H, T, H, T, H, T. Why? Because the condition is head and tail should be alternatively. Okay? M is equals to 2. P of G, M by N, 2 by 8, 1 by 4. Okay? So this is the 7th one. Now last, number 8. Last, getting more number of heads than tails. Getting more number of heads than tails, which means majority heads. Okay, even we know. Event H. Getting more number of heads than tails means, in short, majority heads. Which are the elements? Heads should be in majority. Here it is in majority, here also, here it is not there. Again, this element is acceptable. Okay, so 1, 2, 3 and 4. Heads should be in majority. Triple H, HTH, THH and HHT. So there are 4 such elements. So P of H, M by N, 4 by 8, 1 by 2. So friends, you need to know these things. So what is the difference between exercise 1.1 and 1.2? In 1.1 we have to first write the sample space and only we have to write the elements. Here in 1.2 we have to write the elements and also we have to count the elements and write the probability for each. Okay. So this was our first sum. Now going for sum number 2. So reading sum number 2. 2 balanced dice are thrown simultaneously. Find the probability of following events. Sum of numbers on dice is 6. Sum of numbers on dice is not more than 10. Sum of numbers on dice is a multiple of 3. Product of numbers on dice is 12. Okay. So let's write first the sample space. Again, for finding the different events, we need sample space. After that, we will count the elements. That will our end, and then we will write each and every event. So number 2. Sample space for two balanced dice is U is equals to 1 1 1 2 1 3 1 4 1 5 1 6. This I explained in first exercise itself. Okay, then 2 1 2 2 2 3 2 4 2 5 2 6, then 3 1 3 2 3 3 3 4 3 5 3 6, then 4 1 4 2 4 3 4 4 4 5 4 6, then 5 1 5 2 5 3 5 4 5 5 5 6, then 6 1 6 2 6 3 6 4 6 5 6 6. In each line there is horizontally 6 and vertically 6. So n is equals to 36. Now number 1 under the margin event A is equals to sum of numbers on dice is 6. Sum of numbers on dice is 6. So the elements of set A. First time where you will get total 6 in one file. Now as I said, if you get 1, all will be in a alternate line. 2 4 3 3 4 2 5. Okay. So let's write 1 5 2 4 3 3 4 2 and 5 1. So m will be 5. 1 2 3 4 5. So probability of event A, m by n, 5 by 36. Okay. Number 2, event B. Sum of numbers on dice is not more than 10. So first time around this. Sum of numbers on dice is not more than 10. Then which are the sums accepted? Sum 3, sorry, not more than 10, so sum up to 9 is accepted. Now which are the elements we have to know? I said sum is not more than 10. So first time where the sum is 10, 6 and 4 10. 6 and 4 10. 10 is not acceptable. So 10 will be here, here and here. Because the sum 10 is here. Sum 10 is here. Now all the elements on the left side will be less than 10. All the elements on right side will be more than 10. So these all highlighted elements will not come. All other elements will come. So So set V is equals to 1 1 1 2 1 3 1 4 1 5 1 6 2 1 2 2 2 3 2 4 2 5 2 6 3 1 3 2 3 3 3 4 3 5 3 6 4 1 4 2 4 3 4 4 and 4 5. 4 6 will not come. Now 1 element will decrease. 5 1 5 2 5 3 5 4. 5 5 and 5 6 will not come. Then 6 1 6 2 6 3, because 6 4 6 5 and 6 6 are will not come. They are more than 10. So now let's count the elements. 1 2 3 4 5 6. 6 elements are not there, remaining all the 30 elements are there. So M will be equal to 30. Probability of event B, M by N, 30 by 36, let is cut by 6. So 5 by 6 is the correct answer. Okay. Now number 3, event C is equals to what they are asking. Sum of numbers on dice is a multiple of 3. Sum of numbers on dice is a multiple of 3. So multiple of 3 are 3, 6, 9 and 12. Till 12 is the range, because maximum sum here is 12. So where the sum is 3, where the sum is 6, where the sum is 9 and where the sum is 12, we have to see that elements. So where sum is 3, 1 2 and 2 1. Where sum is 6, 1 5 2 4 3 3 4 2 5 1. Sum 9, 3 6 4 5 5 4 6 3, and sum 12, only one element. So these all are the elements. So 1 2 1 5 from first line, 2 1 2 4 from second line, 3 3 3 6 from third line, 4 2 4 5 from fourth line, 5 1 5 4 from fifth line, 6 3 6 6 from the last line. So 4 3s are 12 elements are there. M is equals to 12. P of C, M by N, 12 by 36, and we will cut by 12, so it will be 1 by 3. Number 4, event B. Product on numbers on the dice is 12. Okay. Product on numbers on dice is 12. Now we don't have to check the sum, we have to check the product. Now for the product 12, 3 4s are 12, 4 3s are 12, 6 2s are 12 and 2 6s are 12. Only that is only possible. 3 4s are 12, 4 3s are 12, 6 2s are 12, 2 6s are 12. So elements will be that itself. 3 4 4 3 2 6 6 2. Okay, because by doing their products, 3 into 4 is 12, 4 into into 12. So we have to write the factors of 12 in short. Okay. So now m is equals to 4, p of b, m by n, 4 by 36, 1 by 9. Okay friends, so this sum is also over. So let's continue the other sums tomorrow. That's all for today. Thank you so much.